Hello and welcome again. Today we will go after the casting that we have studied in the last few lectures. So we will be covering today the important aspects and important topics of this casting processes. So we can see that casting is a process of converting the raw material by melting it into liquid form and then pouring this liquid form into a cavity called casting. So this is the casting that we have earlier studied. We have elaborated all the segments and all the topics of casting, but right now we are again giving a second look to the casting processes so that we have an overview and we have got important topics. We have to know important topics with the examination point of view. What is the important topic of the casting? So casting, as we discussed earlier, is the converting raw material into finished goods by application of heat and without application of pressure. Only in one case we apply pressure, that is pressure die casting. Otherwise we don't apply the pressure. We simply apply the gravitational force of attracting the things towards down towards earth. So we pour the molten metal under the gravitational acceleration into the cavity, into the mold. That is the process of casting. So this is casting process. Cavity is formed within a mold. So mold is the cavity or the part that is used to convert the raw material, the liquid metal, into the solidified. So this is casting. So why it is selected over, why it is preferred over other modules of manufacturing? Because of three basic reasons. One is it is the simplest process that can take place, and it can be applied to all the metals and alloys. And the third one is it does not it is since it is simplest, it is economical process. So because of these three reasons, we choose casting over other methods. And we have discussed earlier that 70 to 90% parts are made up of casting. Because of these three reasons: one is simplicity in making, another is it does not require too much infrastructure, and then we are having a cost effective solution of converting the raw material into uh, production. So because of these three reasons, we prefer casting over other methods. Now these are the advantages as we discussed. What are advantages? Is any form, any complex shape and large shape can be done very well by the casting process. Then we have mechanical properties. Mechanical properties are not good basically in casting. That's why where we form or we make the component by casting, where we don't need much mechanical properties. And so use other solid state process is difficult or uneconomical. So these are the advantages of casting. And then we have applicability of casting, that it can be produced, as I told, 70 to 90% parts are made from castings. So large and complex shape and tunnel features and any types of parts that can be produced, any metal can be produced by application of casting. You can see aluminum alloy casting. We are showing you few castings. These are some uh, parts of automobiles. We are having cylindric cylinders, engines, arrangements, and then aero engine gear case, aluminum, silicon, magnesium alloy made up of castings. So this is magnesium alloy casting. This is also automobile part, main gear housing box. This is, and this is also made by magnesium alloy casting. Then we are having another magnesium alloy casting. Then we are having different parts of automobiles. You can see. So we are having basically three types of casting processes. One is sand mold, the non-sand. We have basically categorized sand mold casting, non-sand mold casting, and precision casting methods. So in sand mold casting, we use green sand, dry sand, synthetic sand, oil sand, etc. Then non-sand are we apply for gravity die casting, pressure die casting, centrifugal die casting, low pressure die casting, counter pressure die casting. These are used where we don't use. These are the die castings where we don't apply, no, don't apply sand as molding material. So these are the third is precision casting, and in precision casting we make mold of various materials including plaster of Paris and plastics and wax, etc. So these are precision casting processes. Investment casting, that is made up of the pattern is made up of wax and the pattern does not is not recovered, whereas plaster mold, POP, and ceramic molds are also there that are used for precision casting processes, and these are used for different types of components, parts, and jewelries and articles and display items, murtis, etc. are made up of these processes. Now, come to the metal casting processes. There are three types of basic metal casting processes: expandable, permanent, non-expandable, non-expandable or permanent mold casting, and single crystal growing. These are three basic types of metal casting processes. Now we come to different types of casting processes: casting tools, component drawing, estimation and quoting, receipt of order. This is the basic criteria. Then sand casting with a core is in place is, we can see these are the basic components and parts that are made of sand casting. Mechanical drawing of part, hook pattern plate, drag plate pattern. These are the, we can see two different types of two different parts of molding flask. Then four boxes are there. Then we are having mold flask. Then these are stepwise allocation of stepwise formation of sand casted materials. So from here to here, we have completely made from drawing to the actual component. This is called, this is sand casting process. So these are different stages that we have discussed in detail. It's time to just to know the important steps and how they take place. So review of casting process: shell mold casting, investment casting, permanent mold, pressure die casting, centrifugal casting. This is shell mold casting, as I discussed earlier. In shell mold casting, the the casting is done by applying a shell mold. So this is the casting. Expandable, we can see it can, the pattern can expand. So these are the different types of parts that are made of expandable pattern casting. So these are the plaster mold, ceramic mold casting. Then investment casting, we discussed earlier. Wax is lost, the pattern is not recovered, is called investment casting. So these are the different types of casting that we are having right now as overview in our today's topic. Precision investment casting, we can see different types of parts. Then we are having mold, discussed mold, core, mold surface, permanent mold casting. So GDC or permanent mold casting. This is metal mold casting or gravity die casting. It is also called. We are having two molds. One is mold this side and one is mold this side, and one is fixed and another is movable. This is the core is kept in between these two. So one of these is movable. This will be movable, and this will be fixed. Then these are the applications. Brake system are made. Brake system of made. Then brake housing is made. These are the gravity die casting because made up of gravity die casting. Then applications, again applications. Then PDC or pressure die casting. We are having, as we are told, that only in pressure die casting we apply external pressure rather than gravitational pull or gravitational acceleration. Whereas in all types of casting we apply gravitational pull as the source of energy. So in that case we pour the molten metal into the mold, and in this case we apply pressure in order to put the molten metal into the mold. So this is hot chamber die casting. We can see it is again using pressure. Then cold chamber again using pressure. So these are PDCs or pressure die casting. So these are the parts and components, alloy wheels and different aluminum, different automobile parts are made by PDC, both hot chamber and cold chamber, hot chamber and cold chamber pressure die casting. Then centrifugal casting is there, where we have applied the centrifugal force, and this way we get a hollow part like pipes, like drums, like hollow chambers, cylinders, etc. are made up of centrifugal casting. So this is centrifugal casting, where the mold is rotated at high speed, and this way the molten metal stuck to the periphery, external periphery of the mold, and this way a hollow shape is created in center. So this is the way, this is the method of performing centrifugal casting, and this is, we can see different types of different components are made up of casting. So this is summary of process capabilities. We can see what are the different, like application different range. Sand casting, it can be done 0.1 to 1 lakh kgs. Any weight, any shape, any size can be given by application of sand, and uh, we can make a casting up to 1 lakh kgs. So this is surface finish is not good in this case, but in most of the cases we don't need part to be good surface finish. So we can normally use sand casting. It is most economic casting. It is most cost effective casting. So we normally apply sand casting. Evaporative casting, we apply, we get a good surface finish, and but thin section, less than 2 millimeter, greater than 2 millimeter, and we apply for a part of 1000 or possibly or 1000 or more parts. We cannot make one or two or five components from any of these type types of castings: evaporative, investment, gradient die, low pressure, and high pressure die casting. These are above all 1000 parts. If we have to make 1000 or more parts, then we can apply evaporative, investment, gravity, low pressure, and high pressure types of castings. Whereas sand casting, we can apply to any number. It could be 1 or 1 lakh. We can apply sand casting easily, but at the same time we don't get very much good surface finish. So 6.3 to 25, and dimensional accuracy is also not good. So parts who are concerned with good surface finish and good accuracy are not casted by sand casting process, or if they are casted, they will have to be machined in order to give a good surface finish to the surface. So these are the summaries, these are the advantages, disadvantages of different types of casting that we have already studied. Sand, it can be applied to any type, any shape, any size, any metal, any model, and but poor surface finish and tolerance can be applied to make engine blocks, to make engine rigs, anything you can make. Whereas shell, expandable, plaster, and have wide range of varieties, and they are limited parts. They are used for limited parts, as well as they give good surface finish at the same time. So these are the advantages and disadvantages of different casting methods. So these are the casting defects. Casting defect is also very important aspect. So where we have blowholes, where swells, scabs, and pinholes, and misalignment, and porosity, and cold shed, and inclusion. These are the defective surfaces. These are the casting defects, and remedies are very simple. We have to take care all the parameters while casting, so they will not produce any of these casting defects. So this was all about today's session. I hope everything is clear. Still not getting any, still not getting anything clear, you may get in touch with me on my phone number, as you know, 9069 360 400. So I'm signing off for the time being. Okay, bye.